Okay, this is number 11, section 7.1. This is another one of the longer problems, a projectile. Recall that the acceleration due to Earth's gravity is 32 feet per second squared. Actually, think of it as negative 32 feet per second squared from ground level. A projectile is fired straight upward with a velocity of 90 feet per second. Okay, what is its velocity after 3 seconds? So, as before, we know that the acceleration is the derivative of the velocity with respect to time. And we're going to set that equal to our negative 32. And then we can multiply both sides by the dt, and we'll get dt, dv dt. Or I should say dv equals negative 32 dt. And then we can take the integral of both sides. And this is a little bit more of a shortcut than we were doing it on problem number 9. We can just basically say that the integral of this will be v of t. V is a function of t because we're not talking about a specific time frame here. So we'll just say this is going to be v sub t, or v as a function of t, pardon me. And that's going to be equal to, if I take the antiderivative, this is going to be negative 32t plus some constant c. So this is kind of generalizing these techniques, and this is a little bit more along the lines of the differential equation method of solving it. And then we're told also that my initial velocity, forgot to put that up here, but v sub 0 was equal to 90 feet per second. So if we want to find out what c is, we know that when t is 0, that equals 90. So we can solve for c putting the 90 in. So when we have 0 here, we say that 90 equals negative 32, and that's when t is 0, plus c. So that becomes 0, so we end up having that 90 equals c. So now we can write our general equation for the velocity at any time, and that equals negative 32t plus 90. And they ask you what is the velocity after 3 seconds. So not how it's changed, but what is it actually after 3 seconds. And this will give you the velocity as a function of time at any time. So all I have to do is put the 3 seconds in there. So velocity when t is 3 equals negative 32 times 3 plus 90. And that's just negative 96 plus 90, which ends up being negative 6 feet per second. So again, this technique kind of gives us the velocity function with respect to time. It kind of gets it a little bit faster than the other method we were doing it. Okay, letter B on the problem. They ask, when does it hit the ground? Well, when it hits the ground, its position. When s, as a function of time, equals 0. It's going to go up and come back down, so the position would be 0. It'd actually be 0 two places, when its time is 0, and then when it hits the ground. So they're asking when, so that's the time, so we're looking for t. S is 0. So we're going to have to find the position function. So we'll go again, we'll start with our velocity as a function of t. And we know that equals ds dt, so we're going to go back another step. And that equals negative 32t plus 90. So I can move the t on the other side, so I'll get ds equals negative 32t plus 90 dt, and then I'll take the integral of both sides. And then we're going to get s as a function of t. So s as a function of t will equal, and then if I add 1, 2, and divide, I'm going to get negative 16t squared. This just looks like our standard position function, plus 90t plus c. Now since we start on the ground, we know that our s sub 0 will equal 0. So if we solve for c, we actually end up getting c equals 0. We can put this in. So again, if we put 0 in, we have 0 equals negative 16, 0 squared plus 90 times 0 plus c, so ends up c equals 0. So there's our position function at any time. Plus 90t. Because our initial position was 0 again. So we want to find out when this is equal to 0. That's easy enough. We can factor out actually 2t. And we'll end up with negative 8t plus 45 equals 0. So either 2t equals 0, and that's t equals 0. That's my initial time, so that's because I started at the ground. And then we have this other possibility, negative 8t plus 45 equals 0. So we saw we'll end up with 45 equals 8t. Divide both sides, so 45 over 8. Oops, sorry. 45 over 8 equals t. And that ends up equaling, actually comes out exactly 5.625 seconds. So that's when it hits the ground, because that's the second time our position is 0. So again, we start on the ground, we go up, we come back down. This is my initial time. So this is when t equals 0, and this here is when t equals 5.625 seconds. Okay. All right, the next part, letter C. Okay. When it hits the ground, what is the net distance it traveled? Well, I kind of showed you over here. We started on the ground, and then we ended up on the ground. So the net distance traveled is equal to 0, right? So we start on the ground, end on the ground. Our net distance traveled is 0. Okay, and then letter D, and this is where it gets to be a little bit of an intuitive approach. Okay, when it hits the ground, what is the total distance it has traveled? Well, the total distance is the distance up and the distance down. Well, this is a pretty symmetrical situation. So the maximum height up here reached sorry about that. The maximum height reached, R-E-A-C-H-E-D. Sorry about that. So the maximum height reached is going to happen that's S as a function of time when my time is halfway. In other words, my whole trip's going to take 5.625 seconds, so my maximum height will be half that. So it's going to be my position at divided by 2. Okay. So we can kind of figure what that position, what the distance is to get to the top of it, and then we can just double it because we're going to go up and down. Okay, so this is the maximum height, so S of 5.625 divided by 2, and then we just put that in our position function, negative 16, that whole thing, 5.625 divided by 2 squared plus 90 times 5.625 divided by 2. And then I did this on the calculator, and what I did was I just set 5.625 divided by 2, and I just stored that in A, using like alpha A. So then I just had to evaluate negative 16 A squared plus 90A. I did that on my calculator, and I end up with 126.5625. That came out exact, so I didn't have to round it off. And I just multiply that times 2, because that's going to give me the maximum height, and that's half of my distance, and I'm going to come back down. So I got this, so this is how you find the total distance traveled, 253.125 feet. Okay. It's maximum height reached. I should fix that. REACHED. Okay, maximum height reached. Okay, hope that was, like I said, that's a little bit more of an intuitive approach. I think you can figure it out. Okay.